Okay, so today we will see two-dimensional motion that is in vector plane. Okay, today we will see two-dimensional motion that is in vector plane, that position and displacement vector. First, look at this coordinate. See, we know already x-axis is denoted by that I. I is the directional you know unit vector along the x, and this is for y, it is j. Okay, now we are considering 2D, two dimensional. Don't consider 3D over here, only for 2D. Now if suppose this red dot you can see in the screen, that is a position, a point, a coordinate. Now what we should do, from that point to the origin we should take a vector, that is basically the r vector or the position of it, and it has a direction. What is the direction? It makes theta angle with x axis. Okay, now what we should do, we basically draw perpendicular on x axis as well as y axis. Okay, now in 3D also, if we have this type of position, okay, suppose it is a force that has been given over there. Now we know this case, like in 3D also we can basically have the if the force is there, we do have the components of force along x-axis, y-axis, and z-axis. That can be represented by force is equal to fx vector, fy vector plus fz vector. Now you see how the position vector varies with parameter. You can see the arrow is getting enlarged. This arrow, initially it was that position and then it is changing. So that means uh, what are those parameters that are basically affecting this position vector? If you assume a position over here, this red point, now if it is proceeding with this distance and finally reaching to this point, therefore you can see the variation of the angle. You can see the variation of the angle getting enlarged. Angle with what? Angle with this axis. Angle with this axis. Now this axis, here it is, normally it has been defined. It is not defined as x-axis something, but you can assume if that is an axis, initially it made some angle with it. Now the angle is gradually increasing, and so the length of the vector also getting increased because the position is getting changed. Okay, now we know this is a distance. If we start from this point and if we want to reach this point, now you can see the curvy ways are actually the distance. Maybe some obstacles are here, so you cannot go directly here. Okay, so you have to basically cover the distance like this. Okay, now this total is that the path taken, that is the distance. Now this is the displacement as per the vector concept, a final and initial. So the green dotted line represents the displacement vector. Now velocity vector, you can see some snails are actually approaching through this green pathway. Okay, so here you can see some are little bit fast, some little bit slow. Now in this pathway, it is not actually that 1D, because you can see a plane, a path through which three snails are approaching. So therefore a path having 2D, two dimension, one a length and then the width. Okay, so now comes to the relative motion. Okay, Now, once we do relative motion in 2D, what we should remember? First thing, like here, if you see somebody is basically standing on a train, railway track, not track, on a train. So here, the relative velocity of that person or maybe the train with respect to the ground, that is one point. And if the person is moving within the train, that is another point. But we'll consider that thing. Let us first just have a concept, like we know something is known as ground reference, something is actually a respective reference that get changed, frame of reference get changed. Okay, now you see here, four persons actually, they are actually traveling by some vehicle. Okay, so the topmost having 10 meter per second, then 20 meter per second, then 30 meter, then 40 meter. So you can see the approach. The 10 meter is reaching, lately. 40 meter per second reaching faster. So that means once they are in motion, they have a relative velocity between them. That means two objects are in motion, they do have a relative velocity in between them. So we need to analyze their relative velocity in 2D. Now, see this case. Motion in plane with constant acceleration. So the first thing, don't get confused with accelerated motion. It is known as constant acceleration. So what we are assuming, whatever the object, acceleration value remains constant. Now you see one orange taxi, another is red taxi. Both are approaching towards each other. Now the relative velocity between them would be the 25 for the red taxi minus of minus 35. How? 25 minus of minus 35. How this thing will occur? Whenever you are considering something is approaching in this way, something is approaching in this way. So you know this is the vector, velocity vector, which is actually positive in nature. In this case, if you are basically observing, by sitting in this red taxi, you are an observer. So you, if the observer in the red taxi, so this is your positive direction. You know the vectors are actually having positive direction towards the right side. Now this is approaching towards it, this is approaching towards it. So what you should do, what you should do here, you should think in that way. When two objects are actually coming each other, towards each other, so why this becomes negative, why this becomes negative? Because then you should think in other way, you should think in other way. Guess how do you think of it? If you are observer here, if you are observer sitting on this red taxi, the trick is that you should give your velocity to this orange taxi in opposite direction, in opposite direction. That means what? That means initially it is coming in this direction. If I take it, this direction as negative, so this orange taxi is actually having minus 35 meter per second. Now what I say, as a thumb rule, you give this 25 meter per second to it. So it is actually a perception, not, you are not actually giving it. It is a perception. The trick, 25 you donate to this, and then you that reverse the direction. 25 initially in this direction towards right, you reverse it, you make it in this direction. 25 again. So minus 35 minus 25. So the relative velocity you are basically feeling while sitting on this red taxi will be minus 60 meter per second. Why it is minus? Because you are considering this 35 to be in this direction, and when this 25 getting donated to this orange thing, it changes the direction, I told you. So then minus 25, so 35 minus 35 minus 25 minus 60. Now if you are considering in either way, this is another a trick or a concept I am giving, another concept also I am sharing, what whichever basically represented here. So if you not consider this type of concept, simply by vector concept, see 25 is there, 25 positive, because this direction we consider positive, so 25 positive. Now this is approaching towards it, so basically relative means what, relative to one with another. So this minus relative velocity you are taking, na minus. Now why we should take plus or minus? Minus 35 because it is towards this direction, and vector towards the left side is minus 35. So it becomes 25 plus 60, sorry, plus 35, that is 60 meter per second. So that you can consider, that is I think little bit convenient way to think of relative velocity. The basic concept is that if you measure relative velocity here, actually this is the relative velocity with respect to this red taxi. The observer is sitting on red taxi, so therefore you are getting in that way. So the thing is that if you are getting velocity of orange with respect to red, so what you should do, velocity of orange minus velocity of red. That is also one concept. Now velocity of orange is somewhat what I have given over here, minus this 35. Okay, and velocity of red is actually here 25. So in that case you don't need to change the direction or anything, as it is you just keep. So plus of minus 25 minus 25, so again you are getting minus 60. So this is also one concept, this is also one concept, and this is what I have given, the donation concept. This is also another concept. It is up to you, you can understand any of this concept. But thing is that whenever two objects are approaching towards each other, two objects are approaching towards each other, then their velocity getting added to get the relative velocity. To get the relative velocity, their velocity getting added. Okay, now so you can remember any of this concept, or better you can remember basic this thing, like if this is approaching, so 25 plus minus of this 35, but it is opposite direction, so minus 35, so plus 60. So this is a best concept. Okay, if you are forgetting which to donate, how to donate, like that you can do like that way. This is also okay. And here only we basically use the vector sign convention. Here it is negative, here it is, sorry, positive, and here it is negative. The basic concept. Now the acceleration vector. So here we are considering constant acceleration. Now the acceleration. So the same concept goes for the acceleration also. You see here, motion in a plane with constant acceleration, if you are taking, see initially the acceleration was 0. If you see this concept, sorry, uh, yes, initially it was 0, then 1 meter per second square, and then velocity in 1 second it changes to 1 meter per second. Then this velocity getting changes because the acceleration is 1 meter per second square, so per every 1 second the velocity is increased to 111, like that. So initially 1 meter per second square acceleration. So velocity in 1 second becomes 1 meter per second, in 2 seconds becomes 2 meter per second, 3 seconds becomes 3 meter per second. Like that it get increases. So it has a linear relationship like that. Okay. Now see, motion in a plane with constant acceleration. In case of motion under gravity also we can consider. See here, if you have this type of ball and that is been thrown in this direction and you are catching it, you are catching it. So generally what you can consider, two things you can do. Whenever a ball is getting dropped with constant acceleration, in every second, 1 second, 2 second, every second, its velocity getting basically increased in terms of acceleration, because it is under the gravity. So we can consider 10 meter per second square. So in 1 second it has reached like 10 meter, 2 second it is 20 meter, 3 second it is 30 meter, 4 second it is 40, like that. So it is up to that. Now if you want to draw a graph like uh, velocity velocity with respect to time, how it will look like. Velocity with respect to time, it will be a linear graph like this, and the slope of the graph will be 10 meter per second square. But at the same time, if you want to draw a graph that is displacement with respect to time, see, these are the velocities that we are getting, 40 meter per second. These are velocities, these are the linear thing with the time. But if we consider the displacement, that is not going to be linear, because in 1 second, initially the velocity, if it falls freely, initially velocity was 0, then in 1 second it becomes 10 meter per second. So the displacement you can take like v square is equal to u square minus 2 g h. Now you need h. V square is actually 10, because in 1 second it becomes 10. U was 0. Okay, u was 0, but you think this v square as this velocity in the downward direction, so it is negative. Okay, negative. Now here what you will be getting, the u is 0, okay, no problem, minus 2, g was 10, and h I need to get. So what is the value of this thing? Like if you are getting it, you are getting it minus 10 whole square, na, v square minus 10 whole square is equal to 0 minus 2 into 10 into h. So therefore h will become minus, because it is downward direction, no problem, h can be negative, downward direction na, displacement negative from that position. So minus 100 divided by 20, so minus 5 meter. So in 1 second it reaches minus 5 meter. Let's now consider in 2 second. So for 1 second it is like that. For next another second, your velocity becomes minus 20 and initially was minus 10. So minus 20 whole square is equal to minus 10 whole square minus 2 into 10 into h. So what it will become? 400, and this is 100. So 400 minus 100, it is 300 is equal to minus 2 into 10 into h. Therefore h will become minus 300 by 20. Okay, so minus 15. So you see, In 1 second it went minus 5 meter, that means downward, 5 meter downward. But in second it went minus 15 meter. That means total displacement is 5 and 15, so 20 meter. So it is not like that it is linearly approaching, it is basically parabolically approaching in that way, increasing exponentially. So we know better ki displacement time graph, if it is accelerated, even though it is constant acceleration, it will look like this only, exponentially increasing, parabolic kind of this. Okay. Now let us move to that next topic. Let us move to the next topic.